Angle modulation. So angle modulation is nothing but the phase of the carrier signal or frequency of the carrier signal is changed in accordance with the message signal or modulated signal, that is called angle modulation. So angle modulation consists of both phase and frequency. So this angle modulation can be classified into two types, that is the frequency modulation FM and phase modulation PM. Phase modulation is nothing but the process by which the change in the phase of carrier signal in accordance with the instantaneous amplitude of message signal. So here the amplitude and frequency of the carrier signal is constant. So generation of PM wave by using FM means we can use the differentiator. So this is the block diagram of generation of phase modulation. First block is modulating signal is connected to the PM modulator, and then we get the phase PM signal, phase modulating signal. So here the next one, the modulating signal is connected to the differentiator, and then the output of differentiator is connected to the FM modulator. So the FM modulator with carrier signal and produce the PM wave. This is the generation of PM wave by using the FM modulator with the differentiator. So here the modulating signal is connected differentiator. The output of differentiator is connected to the FM modulator with carrier signal and produce the PM wave. This is the phase modulation. So phase modulation is nothing but the process by which changing the phase of the carrier signal in accordance with the instantaneous amplitude of the message signal. In the insert, here amplitude and frequency of the carrier signal is constant. Next one, representation of PM signal. So here the PM wave is obtained by varying the phase angle phi of carrier in proportion with the amplitude of modulating signal. So let us consider the modulating signal Vm of t, that is the input signal Vm of t and carrier signal Vc of t. Vm of t is equal to Vm cos omega mt. Vc of t is equal to Vc cos omega ct. So after PM phase modulation, the equation becomes Vp of t is equal to Vc cos theta I. So here theta is the instantaneous phase of the modulated carrier, and it sinusoidally varies in proportion to the modulating signal. Therefore, Pm, the instantaneous phase of the modulating carrier, can be written as theta is equal to omega ct plus kp into Vm of t. So here kp is the constant of phase modulation. We substitute in the above equation. The equation 3 becomes theta is equal to omega ct plus kp Vm of t. That means Vm of t Vm of t equations Vm cos omega mt. So instead Vm of t we can put theta is equal to omega ct plus kp Vm cos omega mt. So here kp Vm is defined as the modulation index Mp of Pm, that is phase modulation index kp Vm. Next one, Vp of Mt is equal to Vc cos omega Ct plus Mp cos omega Mt. This is the Pm wave, can also represented as Vpm of T is equal to Vc cos of omega Ct plus phi m cos omega Mt. This is the Racah phase modulation equation. And then modulation index of Pm. So in that Pm, the modulation index is proportional to the amplitude of modulating signal independent of its frequency. This can be represented as Mp. So Mp is equal to Kp into Vm. So Kp is the deviation sensitivity radians per volt. Vm is the peak modulating signal amplitude in volts. This is the PM wave. So first is the carrier signal with the time, and second is the modulating signal. So comparing this carrier signal versus modulating signal, we get the PM wave. The third signal is the phase modulation waveform. Next one, frequency modulation. So frequency modulation is nothing but the process by which the frequency of carrier wave is varied in accordance with the instantaneous amplitude of modulating signal. In this, amplitude and phase will be constant. So here the process by which the frequency of carrier wave is varied in accordance with the instantaneous amplitude of modulating signal. So here the modulating signal, in generally the FM wave can be generated by using FM modulator, but in this by using integrated we can PM modulator. FM wave can be generated by using a PM modulator. So instead we can use the integrator. In PM generation, instead of integrator, we can use the differentiator, but frequency modulation, we can use the integrator. So here the modulating signal can be integrated. After the integration, this it will be connected to the PM modulator with carrier signal. So this PM modulator can be produce the output of FM wave. So next one, representation of FM signal. So for the single tone FM, the modulating signal Vm of t can be sinusoidal signal. So Vm of t is equal to Vm cos omega mt. So in the instantaneous angular velocity omega is given by omega is equal to omega c plus kf Vm of t. So kf is nothing but deviation sensitivity of FM. By substituting the equation 1 and 2, we get the omega c plus kf Vm cos omega mt. Omega is equal to omega c plus kf Vm cos omega mt. So maximum frequency deviation del f is given by del f is equal to kf Vm divided by 2 pi, or del omega is equal to kf Vm. So integration of equation 3, it gives the angular frequency modulated by phi I. So phi I is equal to integration of omega I into dt. Therefore we get integral of omega c plus kf Vm cos omega mt into dt. So integrate, we can get omega c plus, instead kf Vm we can put the del omega. So del omega cos omega mt into dt. So omega ct plus del omega divided by omega m sin omega mt. So integrate the above equation, we get the phi a is equal to omega ct plus del f divided by fm sin omega m into t. So del f divided by fm is nothing but, instead we can put the del omega divided by omega m. Then the FM wave can be expressed as Vfm of t is equal to Vc cos phi I of t. So phi I of, instead the above equation, we can get Vc cos of omega ct plus del f divided by Fm sin omega m into t. So the ratio of del f divided by Fm is termed as the modulation index. So m of is equal to del f divided by Fm in hertz. So FM wave is expressed as Vfmt is equal to Vc cos omega ct plus m of sin omega m into d. This is the FM wave equation. Next one, this is the output of frequency modulated signal. The first one is the carrier signal, second one is the modulating signal. Comparing these two signals, we get the frequency modulating signal. So compare PM signal, this the frequency modulated signal varying with reference to the phase modulation. So modulation index of FM. So the modulation index of FM can be defined as the ratio of frequency deviation to modulating frequency. Therefore, MF is equal to frequency deviation divided by modulating frequency del f divided by Fm. Del f is nothing but Kf into Vm divided by Fm. So in the AM, maximum value of modulation index is 1, but for Fm the modulation index will be greater than 1. So modulation index MP for PM means MP is equal to K into Vm. So K is the deviation sensitivity, Vm is the peak modulating signal amplitude in volts. So for MF is equal to K1 Vm divided by omega m. This is the modulation index for FM. So M is the modulation index unitless. K1 is the deviation sensitivity, radians per second per volts or radiation per volt. Vm is the peak modulating signal amplitude in volts. Omega m is the radian frequency per seconds. Next one, phase modulation, frequency modulation derivation. So in angle modulated when the general equation is S of t is equal to Vc cos of omega ct plus theta of t. So in Pm the modulating signal Vm of t is the instantaneous phase deviation theta of t. So for theta of t is equal to k Vm of t in radians. So theta dash of t is equal to k1 Vm of t in radians. So if we compare this equation to 1 and 2, 2 and 3, we get integral k1 Vm of t into dt. Therefore, theta of t is equal to k1 integral of Vm of t. So, for phase modulation, substitute the equation 2 in 1. S of t is equal to Vc cos omega ct plus theta of t. Vc cos omega ct plus instead of theta t, we can put the k Vm of t. So we know that Vm of t is value. So substitute the equation 6 in 5. So since S of t is equal to Vc cos of omega ct plus Kvm cos omega m into d. So for S of t is equal to cos of omega ct plus mp. Kvm is nothing but mp modulation index for phase modulation. So instead we can put the mp cos omega m into t. This is the equation number 8. For frequency modulation, substitute the equation 4 in 1. So we get S of t is equal to Vc cos omega ct plus theta of t. So instead theta of t, we can put the k1 integral of Vm of t. So integrate this Vm of t value. So we get the S of t value. S of t is equal to Vc cos into omega ct plus integrate the above. We get k1 Vm of omega m. Cos omega m is integrate function. We get the sin omega mt. So S of t is equal to Vc cos omega ct plus sin m of sin omega mt. This is the frequency modulation equation. So relationship between phase and frequency modulation. So m of t is the modulating signal. It will be integrated and then get the integrate term m of t and produce the phase modulator with the carrier signal produce the Fm. So Fm generation using Pm we can use the integrator. Next one, Fm Pm generation using Fm means instead integrator we can use the differentiator and produce the Pm. So this is the angle modulation types. Types of angle modulation we get the phase modulation and frequency modulation.